All right, hello everyone and welcome. So in this video, we are going to continue our discussion about finding the area between two curves. Actually, we are going to continue our discussion from the last video. So in the last video, we learned how to partition the y-axis and use that to find the area between two curves. Okay, so here's another example. So in this example, if I, for instance, decide to partition along the x-axis, that means to find the area here. So the area that you want to find is the region that I'm highlighting here. So if you want to find the area and if you want to set up the integral in terms of x, you have to divide this region into two parts, right? From right here. Let's see. From right here, because you have two shapes. Think about this, okay? If you draw a vertical line here, and if you draw a vertical line here, you can see here the top is y square and the bottom is minus y square. And here the top is y square, bottom is y plus 2. So they are changing. Okay, the boundaries are changing. So really you have two regions. So this is region 1 and this is region 2. Okay, so you have to separate this into two regions and you need to write two integrals to represent the area of the entire region. One integral for each region to find the entire area. Okay, but how about if we partition along the y-axis? Because if we partition along the y-axis, that means if we draw horizontal lines, see, they are always going between y square and y plus 2. So we just need one integral. Okay, so now let's set up the integral. So the integral in terms of y, so y values are going from, we can see, -1 to 2. Okay, -1 to 2. That's where the y values are going. This is y is equal to -1. This is y is equal to 2. So those are our y limits. And the rightmost function is y plus 2. It needs to be in terms of y. So that's what we have. So x is equal to y plus 2. Nice. It's already a function of y, written as function of y. Minus the leftmost function is x equal to y square. So y square. So subtract these two. And then if you integrate this, so y if you integrate y square over 2, 2 if you integrate 2y, y square if you integrate y cube over 3. So you're going from 2 to -1. Okay, now all you need to do is just substitute the values. So if you substitute 2, 2 square is 4, 4 over 2 is 2. 2 times 2 is 4, minus 2 cube is 8, so 8 over 3. Minus, now plug -1. -1 square is 1, so 1/2, -2. Plus 8 over 3. Here plus because -1 cube is negative and that negative and this negative plus. Okay, so if you simplify this, you're gonna get, I think, 9 over 2. So 9 over 2 unit squares. Okay, so that's the area of the entire region. Super easy to do if you did it in terms of y. Now if you're doing in terms of x, you have to be careful. As I said, you have to divide this into several regions and write two integrals. Okay, right, so I'm going to do one more problem in this video. Okay, that problem is slightly challenging, but in that problem we will write it in terms of x and also write it in terms of y. All right, here's the new problem. So I want to set up an integral to find the area inside this region between these two curves. So that means let's highlight the area. Okay, so let's highlight, and this is the area, this is the region that we need to find the area of. Okay, so what I'm going to do is I'm going to set up an integral using x, and also then I'm going to set up an integral using y. Okay, right, so let's do it in terms of x first. Now if you're doing in terms of x, think about this. Okay, so that means you are thinking about vertical rectangles. So do we have multiple regions? So if I draw vertical lines, you can see here it's going between, the top function is square root 4 minus x and the bottom function is square root 4 minus 4x. That's for this line. But here the top is touching the square root 4 minus x. That's good, but it's touching the x-axis on the bottom. So really, okay, if I use if I partition along the x-axis, okay, to find the area and to write the integral, you have two regions here. Where are the two regions? Let's check that out. It's separated from here. Check that out. I hope you can see it. This is region 1 and this is region 2. Okay, right. So there are two regions here. In the first region, the function is between square root 4 minus x and square root 4 minus 4x. That's the function on bottom and top. But in the second region, the function on the top is square root 4 minus x. So that's good. But on the bottom, it's x-axis, right? So see, they are changed. Where the vertical lines touching on the bottom, they change. So we have two regions. So let's set up an integral to for region 1, x values. So we are talking about x values are going from 0 to 1, right? 0 to 1, first region. And the function on the top is square root 4 minus x minus function on the bottom is square root 4 minus 4x. That's the integral that will give you the area of the first region. Now the area of the second region is C, going from 1 to 4. So 1 to 4, what's on top is square root 4 minus x, what's on bottom is x-axis. So basically you are asking to find the area under square root 4 minus x. So this is it. Or x-axis means it's x is equal to 0, right? No, y is equal to 0, excuse me. Y is equal to 0. So it's minus 0, doesn't matter. So here, this is the integral. So these are the two integrals that will give you the area of these two regions. Okay, right. So now what you need to do is add them up. So if you partition x-axis, this integral will give you the area for x dx plus 1 to 4 square root 4 minus x dx. Right. So it's the summation of two integrals. Now let's partition along the y-axis. Okay, so I'm not going to solve that integral. I'll leave it to you. Okay, so the main idea is I want you to learn how to set up the integrals. Now, if you want to partition along the y-axis, then you're talking about horizontal lines. Now, if you draw horizontal lines, you can see they are always between the same two functions. Right? So you just need one integral. Okay, so y values are going from where to where? They are going from 0 to 2, right? From bottom to top, y values. What's on the function? What's the function on the right? It's square root 4 minus x, but you have to write it in terms of y. Okay, remember we discussed this. So you need to make x subject. So I'll square both sides. So y square is equal to 4 minus x. So x is equal to 4 minus y square. So that's the function on the right. Okay, so I wrote y is equal to square root 4 minus x in a different way by making x subject. Wrote it in terms of y. Minus the function on the left is, okay, it's y is equal to square root 4 minus 4x. Now you have to write it in terms of y. Make x subject. So square both sides. So y square is 4 minus 4x. So take negative 4x to the left. Kick y square to the right, so 4 minus y square. So divide by 4, so x is equal to 4 minus y square over 4. So that's your left hand side function, 4 minus y square over 4 dy. Okay, and that's the integral will give you the area but written in terms of y. Okay, so I'm not going to go over how to solve this integral. So the answer should be anyway 4. Okay, so it's 4 units square, so I'll let you do that. Okay, but the main point that I wanted to highlight is that how to set up an integral, both partition the x-axis and also partition in the y-axis. Okay, right. All right, so that's it for this video. So in the next video of this video series, I'll solve more problems. Thank you.